So let's do a job that's a little bit different than we normally do. In this job, let's record 3 GPS shots. And then let's use our total station with the appropriate scale factor to mix total station data at grid with a grid job. So the first thing we should do is let's make a new file. We'll call it total station at grid. And our GPS is set up. We'll go to Utah Central, Survey, and let's store 3 points. The first point will be the southeast corner of the section. The second point will be the northeast corner of the section. The third point will be the southwest corner of the section. And then let's exit and switch to a total station. Before we take a shot, let's go to the equipment menu, localization, and look at the TS tab. Okay, we've got curvature and refraction checked. I want to apply a ground to grid scale factor to all of my total station shots. I'm going to use the calculator, and I'm going to go to grid coordinates. I'll recall point number 1, which is the southeast corner of the section. And I get a nice scale factor. Click on the green check mark. We'll go to Survey. Okay, let's go to Store Points. We're going to need to do a simple setup, so let's occupy point number 1. Let's backsite point number 5, and let's make our backsite bearing be... So I'm going to aim my total station at the prism that's at the northeast corner of the section. So that's the bearing from 1 to 2, and we'll keep everything kind of flat here. I'll click on backsite, and let's set the angle and read. So our angle right will be 0, our elevation distance will be 0, and our slope distance, let's shoot an even mile. Now you'll see I shot a mile, and the recorded difference is 5279.022. Now if you're paying attention and taking notes, you'll notice this scale factor is not the same scale factor that we calculated on the localization page. And the reason for that is curvature and refraction. So this looks great. Let's accept this backsite, and let's store this as point number 5, and let's call it BS for backsite. Well, let's take a couple of shots now. Let's read. We'll make our angle right be 0, and let's make the slope distance be 5280. We're going to store this as TS2 north. Store as point number 4. Now let's shoot to the west. Let's call that TS2 west. We'll read. Our angle right is going to be the bearing from 1 to 3. And let's make the slope distance 5280. And we'll store that shot. We'll use a new point ID. And then let's go investigate these 2 last shots that we made. Kogo, inverse. let's go from point number 1 to, let's see, the next to last was 5. Just show you that's, no, you want total station to north. And if you look here, you'll see that our ground distance is 5280, and the recorded distance 5279.022. There's the scale factor. Let's go from 1 to the last point that we shot, number 6. Total station to west, and you'll see again we have a ground distance of 5280, but our grid distance 5279.022. This is what we would expect. We're using a single ground to grid scale factor to adjust our total station shots so that they mix in with our grid coordinates. Now you might think this is the end of this video, but you're wrong. There's actually a better way to do this. You probably realize that the scale factor varies everywhere on a job, and it's a function of latitude, it's a function of elevation, and the underlying projection that we're at, so and also the longitude. So if we have a job of any size, the best way to mix in total station data is to calculate the correct scale factor at every point where we set up the total station. And in fact, this is a great way to do very, very large jobs. For instance, a pipeline. Let's say you've got a pipeline that runs 300 miles from east to west. You could pick a state plane zone or a low distortion projection at grid and then use this automatic function that I'm going to show you next so that every total station shot is adjusted independently and mixes in with the grid data perfectly. So let's do that. We'll go to the Equipment tab, Localization. Again, the TS tab. We're going to switch to Automatic Scale to Grid. And then we'll go to Survey, Store Points, and let's get out of this point range and go to point 11. And let's do TS to north. We'll read the gun, so the bearing's going to be from 1 to 2. 5280, we'll shoot a mile shot at ground, and we'll store that. Now for point 12, let's do total station to west. Let's go with the bearing from 1 to 3, and 5280 again. Go back to inverse, Kogo inverse, and let's inverse from point number 1 to point, I think it was 11. Now you'll see that we have a shot distance of 5280, but our grid distance is 5279.035. And let's inverse from point 1 to point 12. This will be a westerly shot. And again, we've got 5280 to 5279.022. So different scale factors when we're shooting in different directions, because SurvCE is calculating the correct scale factor for the vector that we're evaluating with our total station. Again, this is a very, very accurate way to do large jobs because you're not forced into picking a single scale factor that works perfectly in one location and less than perfectly in other locations. So, If you liked this video and think you might want to watch some others that are similar, there's a subscribe button down at the bottom, and if you check it, YouTube will automatically send you a notification when new videos are available. Thanks very much for watching this. Good surveying to you.